If one root of the equation ax square plus bx plus c equal to 0 is the nth power of the other root, then show that ac raised to n whole raised to 1 upon n plus 1 plus a raised to nc whole raised to 1 upon n plus 1 plus b is equal to 0. Let the first root be alpha. Then the second root automatically becomes alpha raised to n. Now what is the sum of roots of this quadratic equation? Alpha plus alpha raised to n is equal to minus b upon a. Let this be equation 1. What is the product of the roots? The product of the roots is alpha dot alpha raised to n, which is equal to c by a. From this we get alpha raised to n plus 1 is equal to c upon a, which means alpha is equal to c upon a whole raised to 1 upon n plus 1. Now substitute this value of alpha in equation 1. We get c by a whole raised to 1 upon n plus 1 plus c by a whole raised to n upon n plus 1 is equal to minus b by a. Now this looks very similar to the above equation which we have to prove. So let us rearrange some terms to see what we get. Let us multiply this equation by a. So a into this whole equation. So what we get when we multiply this by a? So by multiplying a on the both sides of this equation, we get a into c raised to 1 by n plus 1 divided by a raised to 1 by n plus 1 plus a into c raised to n by n plus 1 divided by a raised to n by n plus 1 equal to minus b. Now simplifying this equation, we get a raised to 1 minus 1 by n plus 1 into c raised to 1 by n plus 1 plus a raised to 1 minus n by n plus 1 into c raised to n by n plus 1 equal to minus b. Now by solving this equation, we get a raised to n plus 1 minus 1 divided by n plus 1 c raised to 1 by n plus 1 plus a n plus 1 minus n divided by n plus 1 c raised to n by n plus 1 equal to minus b, which gives us a raised to n by n plus 1 into c raised to 1 by n plus 1 plus a raised to 1 by n plus 1 into c raised to n by n plus 1 equal to minus b. Now rearranging this term, we get a raised to n into c by 1 raised to 1 by n plus 1 plus a into c raised to n whole raised to 1 by n plus 1 equal to minus b, which gives us to a final equation, which is a raised to n into c whole raised to 1 by n plus 1 plus a into c raised to n whole raised to 1 by n plus 1 plus b equal to 0. Hence the proof.